This is a question from GATE 2019 Chemical Engineering, question number 46. A first order irreversible liquid phase reaction A gives B with reaction rate constant K is equal to 0.1 minute inverse is carried out under isothermal steady state conditions in the following reactor arrangement comprising an ideal continuous stir tank reactor and two ideal plug flow reactors. From the information in the figure, the volume of CSTR in liters is dash rounded off to the nearest integer. So this is the figure given. So we can see that there is a stream of Ca0 or Ca which is divided into two streams, one going into CSTR and the other going into a series of PFRs, and we are asked to find the volume of the CSTR in liters. So this is a question from combination of reactors, and we can get the reference NPTEL series in module 1 lecture 27 PFR and MFR in series chemical reaction engineering 1 homogeneous reactors by Professor K. Krishnaiah, Department of Chemical Engineering, IIT Madras. Okay, so now here there are a few concepts that we need to apply. So in the figure we can see that one of the streams is a series of PFR, and the concept is that for PFR in series, let's say there is a PFR V1 connected to a PFR in series with the volume V2, then we can consider this as a single PFR V1 plus V2. Yeah, so essentially if we have two PFRs in series, we can consider that as a single PFR with the volume as the sum of the volumes of the two PFRs. So that is what we'll be using here to solve this question. Now the unknown here is basically the flow rate. So here the total flow rate, they have given the total flow rate nu0 as 100 liter per minute. Now this total flow rate gets divided into two. Let's say this is nu CSTR and this is nu PFR. We are not sure how the flow rate is getting distributed into these two streams. So that is what we need to first find here. Fine. So nu0 will be nu PFR plus nu CSTR. Alright. So now let us consider the case of PFR in series. So we have two PFRs like this, and it is given that the initial concentration Ca0 is 2, it is 1, and the flow rate is nu PFR. Now the volume of the first PFR is 40 and the second PFR is 60 liters. And let's say Ca is the final concentration here. Now the Ca is given as 0.5. We can redraw this like this. So this will be Ca0, which is 1, and the flow rate nu PFR, and the volume will be 40 plus 60 and will be 100 liter volume, and the final concentration Ca as 0.5. Now if we write the design equation for PFR, it will be tau, which is V by nu, and that is equal to integral of minus dCA by minus RA from Ca0 to Ca. Let us substitute all our values here. So we have as 100 liters by new PFR, that will be equal to integral A by RA, and the reaction rate here is first order. So the reaction here is A gives B, and the reaction rate minus RA will be KCA in both the cases. So we'll write that here KCA from CA0, that is 1, and CA, that is 0.5. And also K is also given as 0.1 minute inverse. So now we can integrate this and substitute the values of K also, and we can find the value of the flow rate of the PFR, that is new PFR. So 100 by new PFR will be equal to 1 by 0.1, and that is 1 by K, which is 1 by 0.1, and integral of dCA by CA will be ln CA minus of ln CA from the limits 1 to 0.5. So 100 by new PFR will be 1 by 0.1, that is 10, into ln 1 by 0.5. So new PFR will be 100 by 10 into ln 1 by 0.5. So this is basically, if we cancel this 10 and 100, it is 10 by ln 2. So if we do the mathematical operation here, we'll get new PFR as 14.43 liter per minute. So what this means is basically this new PFR 14.43 will be the value of the flow rate that is going to the series of the PFRs, right? So we had the equation for the total flow rate. Nu 0 is equal to nu PFR plus nu CSTR, and this nu 0, the new total was 100, and that is equal to nu PFR, that is 14.43 plus nu CSTR. So from this we can find the amount of flow rate that is going to the CSTR. So nu CSTR will be 100 minus 14.43, and that will be 85.57 liter per minute. Alright, now let us move on to the CSTR. What we need to find here is the volume of the CSTR. We need to find the volume of CSTR, and for that we will directly use the design equation for CSTR. So the design equation is tau CSTR, which will be V by nu CSTR, and that will be equal to CA0 minus CA by minus RA. So now what we have to do is we have to substitute all the values that we have. So we have the value for new CSTR, we have the value for CA0, we have the value for CA, and this RA is basically KCA, and we have the value for K as well as CA. Now we can substitute all these values and find the volume of the CSTR. So V by new CSTR is equal to CA0 minus CA by Kca. So V by new CSTR, that is 85.57, that is equal to Ca0, that is 1, minus Ca, that is 0.5, by 0.1 into 0.5. So if we do the right hand side, it will be 0.5 by 0.05. So, V, the volume of CSTR will be equal to 85.57 into zero point 0.5 by 0.05. So this is basically 1 by 10. Sorry, that is 10 by 1. So V CSTR will be 85.57 into 10, and it will be 8855.7 liters. And since we are asked to round it off to the next integer, the VCSTR will be approximately 856 liters. The correct answer may vary between 850 to 860 liters. So the volume of PFR CSTR in this question rounded off to the next integer will be 856 liters.